Hello everyone, this is the first recording for day 6 and we're going to be tackling complex numbers again, specifically multiplication and division of complex numbers. So to get us started, let's go back to what we already know. Well, we know how to deal with multiplying and dividing complex numbers when they are in rectangular form. So for example, if I have 4 minus 2i, that's one complex number. 5 plus 3i, that's another complex number. If I am multiplying two complex numbers, how do I do that? Or if I am multiplying one complex number, 4 minus 2i, divided by 5 plus 3i, another complex number, how do I do that? I know you know how to do this already. If you already know it, you can just pause the video and see if you can do it yourself. Okay? For those of you who need a little bit more of reminder. Okay, so this is just multiplying of polynomials. Remember, you can treat I just like you would any variable. So that means it's like 4 minus 2a multiplied by 5 plus 3a. And you're multiplying it. So you are, to do that, you distribute and multiply it out. So 4 times 5 is 20. And 4 times 3i is 12i. Negative 2i times 5 is negative 10i. And then negative 2i times 3i is negative 2 times 3 is negative 6. I times I is I squared. And from this, I can say that, okay, I have like terms that can be combined. Oops, I have to put I squared. Okay. And I also know that this, so here I have 20 plus 20i minus 10i is just going to be 2i. And minus 6. What is I squared? I squared is just negative 1. Remember that I squared is negative 1 there. So I have negative 6 times negative 1 here. So then this simplifies to 20 plus 2i plus 6. Then finally combining the like terms 20 and 6, you end up with 26 plus 2i. And that's my final answer. So when you multiply two complex numbers, you are going to end up with another complex number. Okay, and remember that I squared is same as negative 1. Then it simplifies to just a number. Alright, so then let's try to tackle this where we are dividing. Okay, how do I do this? Well, first thing you need to recognize is that 3i here. Okay, so remember I is by definition is same as square root of negative 1. So that means that there is a radical as a denominator. So there is a radical in the denominator. And we don't like that, right? So what do? We need to rationalize. How do I rationalize this? I need to multiply by its conjugate. What's its conjugate? Conjugate means you get the denominator and it's the same numbers, 5 and 3i. But instead of plus, if it's a plus, its conjugate is minus. If this was a negative, then it's going to be plus. So it's the same number, but the sign in between is different. And if I am multiplying by this to the bottom, I need to do to the top because that is going to be my giant 1. So I am just multiplying by a giant 1 here. And so this is what we are doing here is multiply by its conjugate. Okay, and the reason we are doing this is because a plus b multiplied by a minus b. Remember, these two are conjugates of each other. The numbers are the same, only the sign is different. That is equivalent to a squared minus b squared. This is my difference of square. So the middle term always cancels out. And that is the reason we are doing that. But let's just pretend that we didn't know that and let's just do it as if you didn't know that. Okay, so now when you're multiplying fractions with another fraction, you multiply top with top. So the top numerator just becomes multiplying two binomials just like this. Okay, so it becomes 4 minus 2i multiplied by 5 minus 3i. So 4 minus 2i, 4 times 5 is 20. 4 times negative 3i is negative 12i. Minus 2i times 5 is negative 10i. Negative 2i times negative 3i. Negative 2 times negative 3 is positive 6. I times I is I squared. That's on the numerator. Let's see what happens on the denominator. If I was just to multiply it out as it is. 5 times 5 is 25. 5 times negative 3i is negative 15i. Positive 3i times 5 is positive 15i. And 3 times negative 3 is negative 9. And I times I is I squared. Okay, and notice what happens. This is what I mean by the middle terms canceling out with the difference of square. This negative 15i, positive 15i, they cancel each other to add up to 0. So the denominator just becomes simply 25 minus 9 times, remember I squared is same as negative 1. Okay, so and then on the numerator, I can combine the like term. I have negative 12i minus 10i, so that's going to be negative 22i. And we have 20 minus negative 20i, plus, again, 6 times I squared is same as negative 1. Okay, so then that becomes 20 minus 6i minus 6. So that becomes 20 minus 22i minus 6 all over negative 29. Negative 9 times negative 1 is plus 9. Okay, so I'm sorry, this should be 25. Made a mistake again. Should be 25. Okay, so then again, combine the two like terms. 20 minus 6 is 14. Minus 22i over 25 plus 9 is 34. And I can separate this by separating this as a two different fractions. So this becomes 14 over 34. That's the real portion of the complex number. I'm sorry, you couldn't see that. Okay, minus 22 over 34. I, and each of these simplifies to 7 over 17 minus 11 over 17 I, and that's my final answer. Okay, so what used to look like this has now simplified to this. Great. So now let's see how it works when we are dealing with multiplying and dividing complex numbers in polar form. So now we're going to try to derive the product formula for multiplying and multiplying complex numbers. So to do that, let's consider two complex numbers in polar form. If I say first complex number, and you often use z as to represent a complex number. z1 is r cosine of theta plus I sine of theta. A second complex number is rate m multiplied by cosine of beta plus I sine of beta. Remember, just this is just another complex number, just like this is a complex number, but it is this represented in polar form. Okay, so when complex numbers are represented in polar form, something cool happens. So if I was to multiply the first complex number by the second complex number, this just turns into r multiplied by cosine of theta plus I sine of theta. Multiply that by the second complex number is m multiplied by cosine of theta plus I sine of theta. That's the first thing. Okay, so remember, between the operation between r and the parenthesis is also multiply. So that means we are just multiplying 4 different entities. We're multiplying 1, 2, 3, 4. In that case, the order of multiplication does not matter. So that means I can rearrange this to just multiply R with M. So I can say I am going to multiply R with M first. That's Rm. And then from there, I am going to be multiplying the first parenthesis, cosine of theta, plus I sine of theta, multiplied by cosine of beta, plus I sine of beta. And then from here, when you're multiplying two things in parentheses, you just need to use distribution, don't you? So you're going to do the same thing that you've been doing. Okay, so this just simplifies to Rm multiplied by cosine of theta times cosine of beta. So that's cosine of theta times cosine of beta. We're just multiplying using FOIL or distribution, whatever you like to call it. Then cosine of theta times I sine of theta. Beta is going to be I times cosine of theta and sine of beta, plus then I'm going to do inside I multiplied by sine of theta and cosine of beta and cosine of beta. And then finally I times I is -1, so I am going to put, instead of addition, I am going to put subtraction. Okay, or I can just put I squared for now. I squared sine of theta and sine of beta. Okay? Alright, so then I am going to rearrange this yet again. Okay, so I see cosine of theta, cosine of beta, sine of theta, sine of beta, and of course I squared is same as -1. So this and this, if I combine those, I get cosine of theta, cosine of beta, minus sine of theta, sine of beta. Okay, and what else do I have? If I am dealing with, I can combine both of the i's. Okay, my pen is not working. All right, here we go. So this, actually, I am not going to close the parenthesis because we are not done adding. Okay, so, and to that, we need to add I. I'm going to factor out the I, cosine of theta, sine of beta, plus sine of theta, cosine of beta. And that is going to be my, then close parenthesis right there. Okay, so now what you should notice is, do you notice that this is the sum identity for cosine? Okay, so I can rewrite this as Rm multiplied by, this is, remember cosine, cosine, sine, sine, sine. So this is same as cosine of theta. Okay, so we need to change this to positive. Okay, and then plus I times, okay, so cosine, sine, sine, cosine. That's my sine addition identity. So sine of beta plus beta. Okay. And that is summarized right here. So the product formula for complex numbers in polar form. So if you have complex numbers in polar form and you're multiplying two complex numbers, then you can summarize it as R times M multiplied by cosine of theta plus beta plus I times sine of alpha plus beta.